Leetcode 1879, minimum XOR sum of two arrays. Given two integer arrays nums1 and nums2 of equal length n, you may reorder nums2 in any way. Return the minimum possible value of the sum, position by position, of nums1 I XOR nums2 I after you permute nums2. Constraints: n matches both lengths, n is at most 14, and array values are between 0 and 10 to the 7th. Example 1, nums1 is 1, 2, and nums2 is 2, 3, the answer is 2, one valid order is nums2 as 3 then 2, giving 1 XOR 3 plus 2 XOR 2, which is 2 plus 0. Example 2, nums1 is 1, 0, 3, and nums2 is 5, 3, 4, the answer is 8, for instance nums2 ordered 5, 4, 3 gives 4 plus 0. Nums1 stays fixed in order, you permute nums2. The score is the sum of XORs position by position, we want the minimum. Trying every order of nums2 is factorial in n, hopeless at 14. Instead we track only which indices are taken, using 2 to the n masks. Think of nums2 slots indexed by j. Bit j in the mask is 1 when nums2 at j is already paired, 0 means that slot is still free. For masks for n equals 2, from empty to both indices used. Each circle is one subset of paired j values. The DP moves forward through these states. Read the bits left to right as j equals 0, then j equals 1. This mask has a single 1, exactly one nums2 slot is taken. Popcount counts those ones, here it is 1. In forward DP, that count is exactly how many nums1 positions are already filled. So the next nums1 index I is 1, the second slot, 0 based indexing. Same popcount rule as other forward bit mask DP. For rows, 1 per mask from 0 to 3. 2 bits for 2 nums2 slots. Initialize DP at 0 to 0, empty assignment, and every other row to infinity until a relaxation lands there. Starting at the empty mask, the next nums1 index is 0. First choice, use nums2 at j0. Add 1 XOR 2 to DP, get 3, and relax that into mask 1. Still at mask 0, try j1 instead, 1 XOR 1 is 0, so the cost into mask 2 is 0. Switch to mask 1. Popcount is 1, so nums1 index 1 is next. Bit 0 is already set, so the only free j is 1. Candidate cost is DP at 1 plus 2 XOR 1, that is 6, relaxing into the full mask. Now mask 2. Again nums1 index 1. Bit 1 is set, so use j0. Candidate is 0 plus 2 XOR 2, 0. The recurrence keeps the minimum, so full mask drops from 6 to 0. The forward recurrence is on screen, each candidate adds the XOR at the next nums1 slot. The full mask stores the minimum total for this tiny example, 0. N is the problem size, length of nums1 and nums2. Time is O of n times 2 to the n in the worst case, 2 to the n masks, each inner loop scans up to n choices for j, space is O of 2 to the n for the DP array, the bottom-up loop needs no recursion stack. Quick helper before the main loop, pop count of mask counts 1 bits. Here I equals pop count of mask, that is the next index in nums1 to fill. Function minimum XOR sum takes nums1 and nums2. Let n be the length. Full mask is all n bit set. Initialize dp to infinity for every mask. The empty assignment has cost 0. Loop mask from 0 through full, forward order. Let I equal pop count of mask, the next nums1 slot. Inner loop over j from 0 to n-1. If bit j is already set in mask, nums2j is already used. Continue to the next j. Otherwise new mask is mask or 1 left shift j. Candidate cost is dp at current mask plus nums1 I XOR nums2j. Relax, keep the minimum cost to reach new mask. Return dp at full mask when every nums2 index is placed.